Today we're going to determine whether two ratios form a proportional relationship. In order for two ratios to have a proportional relationship, they have to have the same constant of proportionality. So in this instance, 2 rakes to 14 lawnmowers, in order to find our constant of proportionality, or K, we do y divided by x. That's what we do anytime we find K. Let's call lawnmowers y and rakes x. So 14 lawnmowers divided by 2 rakes gets us a constant of 7, or 7 lawnmowers per rake. And over here we would do 7 lawnmowers divided by 1 rake. That also gets us a constant of proportionality of 7 lawnmowers per rake. So since they have the same constant of proportionality of 7, they are in fact a proportional relationship. We can also apply this to equations. So let's take a look at this equation, and we'll just find a couple data points for that equation. So we'll say, filling in a data table, if x is equal to 0, I just picked 0 because it's easy to work with. We would do 3 times 0 minus 10. I just plugged that value into our equation. I substituted it in. 3 times 0 is 0, minus 10 is negative 10. Well, what if x were 1? Then I could do 3 times 1 minus 10. 3 times 1 is 3, minus 10 is negative 7. So when x is 1, y is negative 7. Let's do one more for good measure. Let's say x is 2. We would do 3 times 2 and minus 10. So 3 times 2 is 6, minus 10 is negative 4. We would expect to see the same constant of proportionality for all of our data points if this were a proportional relationship. So let's try it. Negative 7 divided by 1 is negative 7. Negative 4 divided by 2 is negative 2. This is not a proportional relationship. And in fact, we should know that because when x is 0, y is not 0. I can't do negative 10 divided by 0. We're not allowed to divide by 0. So we know that this is not a proportional relationship. Over here, y equals 9x. We'll do the same thing, make a table of values. And we can even just use the same values of x. So when x is 0, 9 times 0 is 0. So we're already off to a good start. 1 times 9 is 9. 2 times 9 is 18. So let's check and see. 9 divided by 1, our constant of proportionality for this row is 9. 18 divided by 2, our constant of proportionality for this row is 9. So this one is proportional. This one is not. A very fast way to check if it is proportional is, number 1, you cannot add or subtract anything to or from x. You just can't. The other thing is you cannot have any square roots, and you can't have any exponents on x. So x squared, x to the third. All of these will make it not proportional. But if you have y equals something times x, yes, that's proportional because we know constant of proportionality is just the number you multiply by x to get y. Let's look at some tables. So tables work the same way as equations. We've got a point at 0, 0, off to a good start. We have a point here at 5, 4. We have a point here at 10, 8. So let's find our constant. Let's do y divided by x. So 4 over 5 is 8/10. 8 divided by 10, 8/10. They have the same constant of proportionality. It checks out. Would any other point have that same constant of proportionality? Yes, it's just harder to tell what the ordered pair is because they don't fall on whole numbers. That's why I chose the points I did. Over here on this graph, we have a point at 540. And we have a point at, looks like 1060. So let's find our constant of proportionality. Y divided by x, 40 divided by 5, our constant is 8 for that point. 60 divided by 10, our constant is 6 for that point. They do not have the same constant of proportionality. This is not a proportional relationship. In order for a graph to represent a proportional relationship, it has to A, pass through the origin, and B, consist of a straight line. So on the last slide, how I said x squared wouldn't be, that's because its graph would look like this. And you can see that graph has a curve to it. Curved graphs automatically disqualified. Straight line through 0, 0 in order to be proportional. For our last examples, we have some tables, and this is pretty similar, guys. All we're going to do is find the constant of proportionality for each point in the table. So y divided by x. 2 divided by 1 is 2. 4 divided by 2 is 2. 10 divided by 5 is 2. 18 divided by 9 is 2. So even though they didn't list 0, 0 as a point here, because the constant of proportionality is always 2, yes, this is a proportional table. So let's try this one. We've got 3, 7 as a point. So to find that constant of proportionality, we would do 7 divided by 3, and that gets us 2 1/3. I'm going to write over here as a little, I ran out of room. And then we'll do 9 divided by 5. And that actually gets us 1.8. And we can see these are not the same. We don't have to go any further. We don't have to do 14 divided by 10 because we know once two lines of our table have a different constant, it's automatically not a proportional relationship. Let's try this line. 4 divided by 5, that gets us 8/10. 8 divided by 10, that also gets us 8/10. And 12 divided by 15, look at that, 8/10. So it has the same constant for every line. It is a proportional relationship. So just remember, for any of these representations, if you can find the constant of proportionality for multiple points, you can determine whether or not it's a proportional relationship. It just has to have the same constant throughout.